We share
theoretical and empirical reviews.
It is all about learning research facts and sharing with others.
Title of the paper: A meta-analysis on the effects of haphazard motion of tiny or nano-sized particles on the dynamics and other physical properties of some fluids. Author or authors of the paper: Before we present the theoretical review, let us consider a preliminary introduction.
The motion of tiny particles in a sunbeam discovered by the Roman poet Titus Lucretius Carus was associated with a significant difference in temperature or in pressure.
Because of this, haphazard motion and thermophoresis of tiny or nanoparticles are bound to occur wherever there is a significant difference in temperature or in pressure.
A Dutch physiologist, biologist, and chemist that started photosynthesis also discovered an irregular movement of tiny coal dust on the surface of alcohol.
More so, a Scottish botanist observed the random motion of tiny particles suspended in gas or liquid.
It has been confirmed that the migration of living cells is similar to the haphazard motion. This is true because living cells are tiny particles in the vicinity where there is either temperature difference or pressure.
But, what are the major modes of energy transport in any nanofluid?
The result of a research published in the year 2004 shows clearly that the major modes of energy transport in any nanofluid are:
1. Thermal interactions between nanoparticles and the molecules of the base fluid.
2. The collision between the molecules of the base fluid.
3. Diffusion in the thermal property of the nanoparticles, and
4. The collision between the tiny particles due to the erratic random movement of these nano-sized particles.
Next, we shall now present the theoretical review. A decline in the theoretical and empirical review of Brownian motion was observed not just because its relevance lies in the field of mathematical physics but due to the unavailability of statistical techniques. The ongoing debate on transport phenomenon and thermal performance of various fluids in the presence of haphazard motion of tiny particles as explained by Albert Einstein and Robert Brown was further clinched and outlined in the report to conclude based on the analysis of many related published reports, meta-analysis.
Thorough inspections of Brownian motion on the flow of various fluids as reported in 43 published articles were achieved using the method of slope linear regression through the data points and published by the Chinese Journal of Physics. Next is to present the empirical review. 1. Physically, an increase in the Brownian motion-related parameter simply implies an enhancement of the haphazard motion of tiny or nanoparticles.
2. An increase in the magnitude of the haphazard motion of particles implies an increase in the internal pressure on the tiny/nano-sized particles. In such a case, collisions between the particles is bound to occur.
3. Whenever Joule heating is significant, a decrease in mass transfer rate is ascertained due to an increasing Brownian motion.
4. A decrease in the concentration of fluid substance due to an increase in Brownian motion is bound to occur. The corresponding process actually dominates and diminishes the species that formed the concentration. This is not achievable in the case of high entropy generation and Cordic autocatalytic kind of chemical reaction.
5. The Nusselt number, which is directly proportional to heat transfer, decreases due to an increase in Brownian motion. This can be traced to the disturbance of heat transfer owing to the haphazard motion of tiny particles. In the presence of heat and mass convective at the wall of three-dimensional flow, and thermal radiation, a significant increase in Nusselt number due to Brownian motion was seen. See Chatier, 2017.
Moreover, in the presence of Cordic autocatalytic kind of chemical reaction between one molecule of bulk fluid and a higher concentration of catalyst at the surface and nonlinear thermal radiation, it is worth pointing out that Nusselt number can also be increased owing to an increase in mingling motion of tiny 29 nanometer CuO nanoparticles.
It is seen that the rate of decrease in the Nusselt number, which quantifies heat transfer rate due to Brownian motion parameter, is most minimum at larger values of buoyancy parameter and non-similar parameter.
Acknowledgements. Special thanks to all the editors and reviewers of the Chinese Journal of Physics, Elsevier Publishing. We share appreciates the contribution of the authors to the body of knowledge.